Click the bell icon to get latest videos from Ekeeda.
Hello friends, so we are going to study about the derivation for the velocity relationship between the velocities which are occurring during the metal cutting operation. So before starting with the derivation, we have to see the diagram. So as you can see in the diagram over here, this first diagram, this is suppose figure A and this is figure B. As you can see in the diagram that the workpiece, this is the workpiece, this is the tool, and the chip is flowing in the upward direction. So as you can see in the diagram over here, whenever the tool is moving from right to left, the shear deformation occurs, due to which the plastic deformation takes place and the chip starts moving in the upward direction. So here there are the different types of velocities which occur during the metal cutting operation. So here in this derivation, we are going to study about the different relation between the different velocities which occurs during the metal cutting operation. So first we have to make some assumptions. So let us make some assumptions. First, let Vc is equals to the cutting velocity. This is called as the cutting velocity. Next velocity which occurs, that is called as the Vf, that is called as chip flow velocity. And the third that occurs, that is called as Vs, shear velocity. Okay, so these are the three basic velocities which occur during the metal cutting operation. And while doing the metal cutting operation, we have to make a relationship, or during this derivation we have to make a relationship between these velocities, that is cutting velocity, chip flow velocity, and shear velocity. So we will see one by one how to derive the derivation and what is the relationship between these three velocities. So whenever we are doing the metal cutting operation, the cutting velocity is always known to us, because the speed of the velocity, or we can say that speed of the tool which is moving from right to left over the workpiece, is always known to us. So depending upon this cutting velocity, we have to find the relationship between these three types of velocities. So first we have to assume a triangle. As you can see in this second diagram, AOB, in this diagram these are the three velocities which is moving. So first velocity, this is the velocity cutting velocity, this is the second velocity shear velocity, and this is the third velocity, that is a chip flow velocity. This is the angle, or we can say this is the phi angle between the shear velocity and the cutting velocity. The angle between the chip flow velocity and the shear angle, it is making phi angle plus 90 minus alpha plus 90 minus phi angle. So one by one we will see what is the relation between this three types of velocities. So we have to consider this first triangle OA and B. So in this triangle OAB, we can write as Vf upon sine of phi is equals to Vc upon sine of 90 minus phi plus of alpha, or it is equals to Vs upon sine of 90 minus alpha. So from this triangle we can get the equation as this chip flow velocity upon sine of phi is equals to Vc, that is chip cutting velocity divided by sine of 90 minus phi plus alpha is equals to Vs, that is shear velocity divided by sine of 90 minus alpha, or we can write it as Vf upon sine of phi is equals to Vc upon cos of phi minus alpha. Here we get that as we have seen earlier in the derivation, that sine of 90 minus theta is equals to cos of theta. This is the assumption, or this we can say this is the standard formula. So from this we get that Vf upon sine of phi is equals to Vc upon cos of phi minus alpha, or also we can write as Vs is equals to Vc cos of alpha divided by cos of phi minus alpha. Also we get the equation as Vf is equals to Vc sine of phi divided by cos of phi minus alpha. So we have got the two equations. Suppose this is equation number 2. This is my equation number 1. So we have got the equation for Vs, that is shear velocity, and also have got the equation for the Vf, that is flow velocity. So we also know that in the previous equation we have got that, or in the previous derivation we have found that we also know R is equals to sine of phi divided by cos of phi minus alpha. This is equation number 3. This equation number 3 we have derived in the previous equation or previous derivation in terms of chip thickness ratio. So from that, by considering these three equations, we get Vf is equals to Vc into R as in orthogonal cutting system. So this is the basic equation. So this is the basic equation to find the flow velocity, that is equals to Vc into R, where R is called as the chip thickness ratio. So this was the final relationship between the velocity relationship between the different velocities which occur during the metal cutting operation. We will take a quick revision how they are getting derived. So this is the diagram figure A, where you can see there is a workpiece, there is a tool, and the tool is moving from right to left, due to which the chips are getting formed. There are three types of velocities which occur during this metal cutting operation. The first velocity is called as cutting velocity. The second velocity is called as chip flow velocity. The third velocity is called as shear velocity, and this for getting the values or getting the relation, we have to consider a triangle, that is AOB. In this second figure you can get this triangle AOB. From this triangle we get the equation as Vf upon sine of phi is equals to Vc upon sine of 90 minus phi plus alpha is equals to Vs upon sine of 90 minus alpha. Or we can get, or we can say Vf upon sine of phi is equals to Vc upon cos of phi minus alpha, where I have taken a simple equation, or we can say standard formula, sine of 90 minus theta is equals to cos of theta. So Vs is equals to Vc upon cos of alpha divided by cos of phi minus alpha. Or I have got a second equation, that is Vf is equals to Vc sine of phi divided by cos of phi minus alpha. We also now know that R is equals to sine of phi divided by cos of phi minus alpha. This equation we have derived in the previous equation or previous derivation in terms of chip thickness ratio. So final equation we get it as Vf is equals to Vc into R. It is in condition where orthogonal cutting system is there. Whenever there is orthogonal cutting system, we have to get this equation to find the relation between the, or we have find the velocity relationships. Thanks for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.